Hello everyone, welcome to another video. And today we'll be solving, we'll slightly like start with a different study plan, which is dynamic programming plan, which is this one. Okay, this you can see. These are selected problems from dynamic programming. So we'll start with a very basic problem so that um, it gets everyone is clear to like what is dynamic programming or what we are trying to achieve with that. Okay, so. Okay, let's get started. First of all, this is the Fibonacci number. So the question says that Fibonacci numbers, commonly denoted Fn, form a sequence called the Fibonacci sequence, such that each number is the sum of two preceding ones, starting from 0 and 1. Okay. Uh, so in other words, what it is saying is basically you start with 0 and 1, and to get f of 2 in this case, you will add the previous two numbers, which is f0 and f1. So you will get 1 again. So what if I were to explain it from on a whiteboard? Let me just go there. Okay. So what it says is, so you start with f0 equal to 0 and f1 equal to 1. So to get f of 2, you are required to do 2 minus 1 plus f2 minus 2. So you have to do this thing. So 1 plus 0 equal to 1. F2 is equal to 1. Similarly, F3 will be F2 plus F1. 1 plus 1 equal to 2. So you can verify that it is 2. Similarly, for n equal to 3, n equal to 4, you will add 2 and 1, we will get 3. So we have to write a code to calculate, given an n, we have to calculate f of n, which is Fibonacci of n. So how we can do it? Okay, let's try to figure it out. One way is to use recursion. Okay, if you don't know recursion, it's a good idea to refresh that. But recursion is just basically a function calling itself. Inside this function itself, if we call fib of something, some argument, then it will be called as a recursive call. Okay. So how can we do it recursively? Let's try to find out. Okay. Let's try to visualize it. So let me clear this out. Hopefully it's clear to everyone. Okay. So let's take an example where we have to provide this value. Given an n, we want to find phi of n, and the formula has been already given to us. This is our reference, okay? Fib of n is equal to fib of n minus 1 plus fib of n minus 2. Okay, so by recursion, what we can do is for this one, we can call fib of n minus 1, fib of n minus 2. And if we have these two information, we will get fib of n. But to get this in turn, we will need fib of n minus 2, fib of n minus 3, and so on. But we have already calculated fib of n minus 2 here. So why there is a need to call the recursive call on this argument again? This is where dynamic programming helps. So it's kind of what we can do is we can maintain a lookup table. In a lot of optimization techniques, we tend to use lookup tables. Use a lookup table. So if you've calculated this, store it. Let's call it store, okay? And when you are required to ultimately fetch this value again, you can directly fetch it from store. That is one way to approach this problem. So first, let's try to write the code, recursive code, okay? Let me go back. So it says public int fib of n. So with recursion, there's always we have to specify the base condition, okay? Which means what will be the terminal condition, okay? If we don't specify terminal condition, it will keep on going to n minus 100, n minus 101, and so on. Recursion will never end in this case. So terminal condition is very important with recursive calls. Okay. So in this case, it's a good idea to have a terminal conditions like, for example, if n is equal to 0 or n is equal to 1, return n. Because if n is 0, then the return value is always 0. Okay. As you can see here, fib of 0 is 0, fib of 1 is 1. Okay. Now, what we can do is we can just directly call without doing any optimization. We know fib of n, how to calculate it. Okay. So we do this. Okay. This is the way. So in the return statement, we can directly do something like return. Okay. Let's try to type out this code. Okay. This is recursive code, so that's why it's very short. Let's try to type it out and see like how it works. You see, that much code is working fine, but n can take value up to 30, which you will see. Let me give 10 here. Let's see, 10 also works. Can we give 20? 20 also works. Let's try to give 30. So it is working fine as it is. Okay, so basically, um, it should work actually. It will be accepted. So we can try submitting it. It should work actually. So hopefully this recursive code is very clear to everyone. What we do is we have a base condition where n is equal to 0 or n equal to 1. We directly return that value. Okay. Otherwise, we use this definition where fib of n is dependent on fib of n minus 1 and fib of n minus 2, and we type that in the return statement. So the tree, recursion tree, will look something like this as I have shown here. Okay, it will keep on going like that. To give you a more clear example, if it is not clear still, let me take fib of 3. So fib of 3 will require me to calculate fib of 2, fib of 1. This in turn will require me to calculate fib of 1, fib of 0. Similarly, fib of 0, that's the base condition we have reached. So I don't think anything further is required here. So this is how a sample tree. Okay, so hopefully recursion is clear to everyone. This in this case, let's try to submit it and see the runtime here in this case. As you can see, runtime is not that great actually. It shows 35.41%. It takes 9 millisecond. Okay, so it's much slower than compared to majority of the solutions. Why? Because those people have used the dynamic programming technique, which will be used now. Okay, now here think about, let's go back to here as I discussed. If we have already calculated fib of n minus 2 here, why there is a need to calculate it again? We can just do an optimization where we can store this value, okay, in some array or something. So that's what we do in favor dynamic programming. So we'll store it. Let me go back to the code. Maybe we can use an array, okay? So every time we calculate fib of n minus 2, we will store it. So what we can do is we can call a fib, it can be n plus 1. Okay, I'm just thinking of a way where it will be easier to read this code. So fib of n minus 2, once it has been calculated, we can store this value. Oh, okay. So that's what we will be doing. Every time we calculate, we get one of the fib values, we will store it in a certain index. So fib 0 will store fib 0. If okay, it's like this. Now we just need to iterate, I think from 2, because fib fib of 0 and 1 are the base conditions. And at the end we can just directly return fib of n. So just to give you an iteration, so fib of 0 and fib of 1, which is line number 8 and 9, should be very clear. There shouldn't be any doubt about it. Okay. But this formula, as it is shown, it is valid for n equal to 2 and upwards. So we start from I equal to 2, we go till whatever n is provided to us. Okay, do a for loop here. Okay, so yeah, we just apply the formula and we keep storing the fib values for each integer value till n. Okay, that's what we are doing here. So if we try to run it, it works actually. Time and space complexity point of view, if you look at it, so time still like it will be going over all of the values. That time complexity will still be O of n, and space complexity will be again O of n because it's storing the fib values for each of the n provided. Okay, there are some optimization that you can still do. Instead of array, you can just maintain two variables. Uh, but this is good enough actually for this problem. If we submit it, it will be submitted and it will find it should take faster than 9 milliseconds. Yeah, see, it's showing 0 milliseconds. So beats 100%. Memory is not beating actually a lot, but memory also we can improve, I think. Let's try to improve that as well. So we just need to figure out because at any point of time we are just using the last two previous values of in the fib array, right? We are not using all of the previous values. For example, to give you an idea, let's say our fib array looks like this. So for example, if we are calculating this fib value, we are only concerned about with the previous two. Okay, we are not concerned about these all. So that's where we can do the space optimization that what I'm trying to do right now. So fib of n will be fib minus 1 plus fib minus 2 actually. Fib n minus 2, fib n minus 1. Okay. Now fib n minus 2 will become fib n minus 1 and fib n minus 1 will become fib of n from the next iteration onwards. Let's see if it is working or not. Yeah, it is working. Should work. Let's see. I think it should work. Let's see. Network issue. Yeah, so it is working and the memory is also beating 98.55% of the submissions. So yeah, this is another optimization that you can do. Time complexity in this case will be, so we are still iterating over all the n values, so it will be O of n. Space complexity is O of 1, constant. Because we have only three variables that we are just trying to messing around with all these three variables only. So that's all I had to share for the Fibonacci number. Uh, let's meet in next video, which will be on this nth Fibonacci number. It will be similar to this one, not much variation, but for the sake of clarity, we will still do that. Okay. So hopefully this was helpful. Thanks.